Okay, let's take a minute and begin talking about Newton's first law of motion. Newton's first law states that an object in motion will stay in motion until acted upon by an outside force, and an object at rest will stay at rest until acted by an outside force. In turn, this whole concept kind of deals with the mass and the unbalanced forces. If the net force is equal to 0, then I have 0 acceleration. Let's look at this example problem. A 0.5 kilogram cart is rolling at a speed of 0.4 meters per second. If the speed of the cart is doubled, the inertia of the cart is it A, halved, B, doubled, C, quadrupled, or D, unchanged? Well, if I think about the first law, then I've got to know that inertia deals with mainly just mass. So if I look, the answer should be unchanged because mass is a measure of an object's inertia. And the mass of the cart is constant. So if the mass doesn't change, the inertia doesn't change. So in this one, over that example, let's look at this question. Which object has the greatest inertia? A falling leaf, a softball in flight, a seated high school student, or a raising helium-filled toy balloon? Again, in turn, remember, inertia deals with mass, so think about mass when you look at this answer. The answer would be a seated high school student has the greatest inertia, or the greatest mass. Which object has the greatest inertia? A 5 kilogram mass moving at 10 meters per second, a 10 kilogram mass moving at 1 meter per second, a 15 kilogram mass moving at 10 meters per second, or a 20 kilogram mass moving at 1 meter per second. So the whole deal, again, is we got to think is dealing with inertia. And remember, inertia is looking at the mass. So by remembering that, let's look at what the answer should be. The answer should be a 20 kilogram mass has the greatest inertia. The one that has the biggest mass is going to have the greatest inertia. Okay? Mass and inertia are directly proportional to each other. Big mass, big inertia. Little mass, little inertia. Not a hard concept to remember. Okay, guys? So let's put that in terms. If I have a big inertia, I have a big mass. Don't forget, they're directly proportional.